number of different propagation phenomena, and radio amateurs have put up beacons on VHF, UHF, gigahertz frequencies so that we are able to actually listen to propagation. Some people tell me that amateur radio was one of the first social medias, so we do promote international friendship and understanding. That's still an important thing. One thing that's very important to me is to provide learning opportunities. As I said, I came into my professional job through amateur radio, so we have the possibility to teach people, to motivate people to learn electronics, telecommunication, radio wave propagation, and in that way paying back to the society by preparing human resources for government, for industry, not really for ITU yet, but still for the government. There are nearly 3 million licensed radio amateurs worldwide, and the radio amateur community continues to grow, both in membership and in technology. So what about space then? The very first one was before I was interested in amateur radio back in 1961, with the first OSCAR, which stands for Orbiting Satellite Carrying Amateur Radio, and the first two-way amateur satellite contact, I've been told, was between Germany and Switzerland via OSCAR 3 in March 1965, which is quite some years ago. And since then, there's been many projects with satellites carrying amateur radio. Largest spacecraft was OSCAR 4 in 2000, with more than 500 kilo launch mass. And the longest lived, still going strong, is OSCAR 7. That was put up in 74. There are specific AMSAT, that is amateur radio in space, organizations in more than 24 countries. And as you probably all know, there are radio amateurs on board the ISS, and quite a lot of the astronauts going there either have their radio license much before they become interested in going into space, or they do a test before going on. And then I've come to something of the thing that we spent quite a lot of time with. A number of amateur satellites have been designed and constructed by university students with the help of local amateurs and amateur satellite organizations. And here are just a few examples. I'd like to add on to that that gives a lot of benefits to the amateur community. It inspires people to be interested in amateur radio and electronics. It is also quite a lot of our members that find interest in listening to the satellite, being able to receive telemetry data, being able to understand them. I put up a slide here just to give a picture of what is flying today. So as far as I could count, and maybe one or two off here, but the number of current active satellites in the amateur satellite service allocated bands, and I'll come back to that later, is like this. It's 44 that has a downlink or a beacon in our 70 centimeter band, the 435 megahertz band. There are 8 satellites with downlinks or beacons in the 2 meter, the 145 megahertz band. And at this moment, I believe there are 11 satellites which incorporate some kind of transponders or repeaters. Still some FM voice repeaters left, some 6 linear transponders, and 2 digital satellites. That's of today, but tomorrow looks even, I almost say worse, but the numbers are higher. As Attila already showed us, the number is going up, and we foresee for the next 1 or 2 years that there will be over 100 projects at least planned for launch. And 50 of these are CubeSats, the Cube 50. I only know of one geo stationary. All the others are LEOs. And this geostationary we'll hear more about tomorrow, I think. So I may be attacking this from the wrong angle, because I have already assumed that we have sorted out that we're in the amateur satellite service. And then there is a number of bands allocated to the amateur satellite service, as Attila already showed us. I have started here on 28 megahertz. I do not know of satellites on lower frequencies, but we also have on lower HF frequencies. In some of these bands, the amateur satellite service is primary. In a primary, you can claim protection from interference from secondary sources or secondary users. While if you are a secondary service, you shall not cause interference and you cannot claim protection. So there's quite a difference. But within an amateur band, there are no rules of who owns the frequency, who can claim protection from interference. In the amateur bands, we have to figure that out ourselves. So this is the self-regulatory part of amateur radio, where we try to sort this out as best we can. I'd like to point to two mechanisms. And of course, these bands, some of them are amateur allocations and some are amateur satellite allocations. But for all of them, we have agreed on what we call band plan. And band plan, we put users in different parts of the band, different users, using, for instance, different modulation. Yeah, all of you know that if we had put a lot of terrestrial FM repeaters in the same band as satellites, that wouldn't work. So we try to differentiate them in that way. The other way is, of course, what's the main topic here today is frequency coordination, to put different users on different frequencies. And all this is done to minimize or avoid interference. Neutral interference, interference to other services, and especially harmful interference to primary users where the amateur service is secondary. I put up 2 slides of the frequency bands, and I'd like you just to focus a very quick second on the 2-meter band, where the satellite segment is very much smaller than the whole band. The whole band looks like it's 2 megahertz, but the satellite portion is, there is a small part in addition to what is set up here, but mainly just above a few tens of kilohertz. While when we get up to 70 centimeters, we've got more space. But on 70 centimeters, you can see then there was secondary again. Same situation up in 23 centimeter, and it goes on. We have to go quite high in frequency until we get a primary allocation. And if any of you are following this presentation from the memory stick, I am very sorry, but I missed out on a footnote. And footnote and radio regulation is important, we have learned. So on the 4 millimeter band, on the last 81.0 to 81.5 gigahertz, I missed that out in the beginning, and I've sorted it out here now. I am not aware of any amateur satellite in that frequency range yet. So now I'm coming back a little bit to the amateur satellite service and who can use the bands allocated to the amateur satellite service. And as we saw of the definition earlier on, it is a licensed radio amateurs. And a license is a national amateur radio license. The radio regulations have a distinct definition of a radio communication service for the purpose of self-training, intercommunication, and technical investigation carried out by amateurs, that is, by duly authorized, here comes the licensing in, duly authorized persons interested in radio techniques solely with a personal aim and without pecuniary interest. So it's stated that you need a license. It's stated that you should not earn money on this. Those are the two main important issues there. That's also where we can do discussions on university projects, and where we have maybe sometimes of a gray zone. But what is important to us as radio amateurs is that the university projects don't take us over the edge, don't start to sell things and gain money on it, because then we get criticism. That means that if you have a project and you are not sure if this is within the scope of the Amateur Satellite Service, I would recommend that you contact the National Amateur Radio Association. Also, you could contact the Amateur Satellite Association. But in the end, it's actually your national administration's responsibility to tell you if this is within the scope of the Amateur Satellite Service or not. So sort this out as early as possible to avoid unpleasant surprises. So I don't really need to say what is written here. We all have discussed it so much today, why we need frequency coordination. We want to minimize or possibly eliminate interference. And we've had several suggestions of when to start this frequency coordination request. I hear some that say that we have to start first. We would like you to, in your project, to approach your administration as early as possible, so that we can start as much as possible of this in parallel. We've talked about maybe having a limited time for small satellites, so if we start all in parallel, that will be the very best. It is important for the radio amateurs, for IARU, that you do your notification with ITU according to the procedures that we have learned. And it is important for us also that the missions are recorded in the master register of ITU, because we as amateur, we are in the second line when it comes to discussing frequencies. And we do this at all WRCs, and we fight for our frequencies. And we need to show that our bands are used. Coming back to what was said earlier, use them or lose them. We need to show that our bands are used. And who makes the frequency coordination request to IARU? And that is the licensed amateur radio operator. The one who holds the license, who is responsible for the license for the transmitters. To sort out or to actually coordinate, perform the IARU coordination, we have a satellite advisory panel, and I've listed all the members here on the panel. We are happy to have Graham Shrivel with us here, so if we have detailed discussions on that, Graham can help us. Of course, all of this information is available on the IARU.org/satellite web, and there you will be guided to the AMSAT UK web, where you find additional information. I know this is not easy to read, but the URL should be easy enough. And so the procedure to request an IARU frequency coordination is of course first to determine